Hello everyone and welcome to the today's session. So today we are discussing how to draw the top and sectional front view of a double riveted lap joint with zigzag riveting. So let me discuss this joints with a simple problem. You can see here the problem is given as draw the top and sectional front view of a double riveted lap joint with a zigzag riveting. The thickness of the plate is given as 9 millimeter. So initially the thickness will be given in the problem. By using this thickness of the plate, you have to derive the remaining portion of the joint. So such as this diameter of the rivet. Uh, 6 fruit T, we got it as 18 millimeter. The longitudinal pitch P equals to 3D, so 54 millimeter. Similarly, the margin M equals to D, 18 millimeter. The distance of the center of the rivet to the edge of the plate is 1.5 times the diameter is 27 millimeter. So that distance is nothing but the center of the rivet to the edge of the plate. This distance is 1.5 times the diameter, both sides you can see here. Similarly, the transverse pitch for zigzag riveting is given by 0.6 times the pitch. If you substitute this pitch 54 millimeter, we got it as 32.4 millimeter. This distance is nothing but the distance between these two centers. That is PT is given as you got it as 32.4 millimeter. The diagonal pitch PD is given by the formula 2 times the pitch plus diameter whole divided by 3. We got it as 42 millimeter. This diagonal pitch is nothing but the distance between the center of this rivet to the center of this rivet in a diagonal direction. You can see here. So this distance is PD. So no need to maintain this PD dimension to measure every time. Automatically, if you maintain a gap of half of the pitch for the second line of rivet, so you can see here the distance between center of this rivet to the center of the second line rivet is 0.5 times the pitch. That is nothing but half of the pitch. The distance between the center of this second rivet to the first rivet is here to this center to this center distance is given by 0.5 times the pitch. If you maintain this gap this distance in the second line, you can automatically get this distance PD. So no need to maintain this PD exactly here. So this dimension you will automatically get. So next is the radius of the rivet head. Similarly, that is 0.8 times the diameter, that is 14.4 millimeter. Similarly, the rivet height of the riveted head is 0.7 times the diameter, that is 12.6 millimeter. So I will draw this joints in the solid edge software. So you need to observe the procedure carefully and you need to draw it in the drawing sheet. The procedure remains same. So let me discuss this solution in the solid edge. So I'll start with the center line. So the distance between second center line, that is PT, you can see here PT we got it as 32.4 millimeter. So another center you have to draw a distance of 32.4 millimeter from this line. So 32.4. So next, from these two centers you need to maintain a distance of 1.5 D, that is 27 millimeter. So now you have to draw the two plates of thickness 9 millimeter. So now you have to draw the taper line. You can see this 10-degree taper line. Only the 10-degree taper line here. Remaining portion you trim it. So this length you can draw it for any length as explained in the earlier problems. Similarly, this length also you can draw it for any length. This is the length of this plate. You can draw it for any dimension, any length. So now you have to concentrate on drawing the diameter of the rivet, that is 18 millimeter, so 9 millimeter from the center. Similarly here. Now you have to draw the radius of the snap head here. For that procedure is there. First you need to leave a distance of height of the snap head as we got it as 0.76, 12.6 and 14.4 millimeter, 12.6 mm. First you need to draw a 12.6 mm distance. So another is 14.4 mm. Millimeter. Okay. Now you extend it, extend the center. Now draw the line from this diagonal to this diagonal. Now you have to draw the bisector of this line to get and extend this bisector till it touches the center of this rivet. So that will become the center for drawing the radius of the snap head. So bisect this line. This bisector you need to extend till it touches the center of the rivet. So we got the new center here. So this is the center to draw the radius of the snap head. So from this center draw a radius equals to, draw a arc of radius equals to 14.4 millimeter. So remaining portion you delete it. this is about so we need the center. So similarly you have to draw the bottom portion of the snap head here. So no need to again drawing the snap height of the riveted and the radius again to bisect that lines. Instead of that, you just measure the distance from this line to the center, and same distance you give in the bottom to get the new center for drawing the radius of the bottom portion of the snap head, as explained in the previous videos. So measure this dimension from this line to the center in the vertical direction. .93, we got it as 1.93. So you leave a gap of 1.93 from this line. So this is the new center for drawing the bottom portion of the snap head. So from this center you draw a arc of radius equals to 14.4 millimeter. This is about drawing the bottom portion of the snap head. So similarly you have to draw this center, this snap head in the second rivet. So instead of again doing these things again bisecting, so just you can transfer these centers to this center line of the rivet as explained in the earlier videos. So you transfer the centers to this next center of the rivet. So here is the new center for the drawing second rivet head, snap head. So from this center you draw the radius equals to 14.4 mm. Similarly here 14.4 mm from this center. So drawing the front view. So next you have to concentrate on drawing the top view. So I'll start this top view with this any center you can start from anywhere. So I'll start here. So now the distance pitch P is given by you got it as pitch P as 54 millimeter. So pitch P you have to leave here, here and here and here. So you draw three centers here of a distance equals to 54 millimeter from this first line. So this in the second line, so since it is a zigzag riveting, the second line, the center for the rivet in the second line here it is 0.5 times the pitch. Okay, so now you have to offset it for you have to draw a new center in the second line as 0.5 times the pitch. So 0.5 times the pitch means half of the initial pitch. This is 54 millimeter. Half of this pitch is 27 millimeter. So you offset it for 27 millimeter, or you just draw another center here for this. It is 27 millimeter. Second line of the second rivet for zigzag riveting. Similarly, now 27 millimeter from this center now. 27. This is the center for second line of the. This is center for the second rivet. So now the two circle as usual. First circle of diameter equals to 18 millimeter. That is diameter of the rivet. 18. Now centers. Now so this center is here. The center is here, 18 millimeter. So another circle of this projection. So draw another circle here. So inside circle you have to make it as dotted because it is invisible. Now just cross check the diagonal pitch whether it has come as for our dimension. We have got it as 42 millimeter. So just cross check whether you got it as 42 millimeter. So have to cross check that diagonal pitch has maintained. So you can see here we got it as 42 approximately, so that means our solution is correct. So approximately we'll get this dimension. There is no need to get exact 42 millimeter. Okay, so remaining the portion you have to complete here. So sectional front view, for showing the section, you have to section here. This portion you have to section. So when you section this portion, so you can see here the section of this you can see off only here. So there is no rivet in this portion. So you can see the plate here. That means while showing the section in the front view, you have to section whole these plates. This one, and this one is invisible because this rivet will come backside, so you cannot see this rivet. So similarly, rivet in this section to make it this as section. So there is no rivet here, so you can see this rivet only. So that's why you have to make this line and this line as a dotted. So the remaining portion you have to make it for completion. So completes this bottom top view. You can see here you have to mention the imported dimensions, and before that you have to draw the section here. This is the section here. This is the section line. So if you section this, you cannot see any rivet here. So that's why I have drawn here in the dotted lines. This is section A. The important dimension you need to show here. So distance between these two center is PT is given as 32.4 millimeter. We got it as 32.4 millimeter. Similarly 1.5D distance from this center to this edge of the plate is 27 millimeter. Similarly here this dimension from this center to this edge is 27 millimeter, and the distance between these two centers is pitch P is 54 millimeter. Similarly this distance is 0.5 times the pitch, that is 27 millimeter, half of the pitch. So this diagonal pitch is automatically maintained, no need to maintain this distance. Okay. Thank you for watching.